Hi, my name is Rob Hoskins. I'm a research and development engineer with Prosthetic Design Incorporated and a clinical consultant for Dayton Artificial Limb Clinic in Dayton, Ohio. The reason we're here today is to talk about Prosthetic Design's Elevated Vacuum Locking System, or EVLS. The EVLS is Prosthetic Design's modular push shuttle lock, which is conducive for use with elevated vacuum socket systems. To fit properly into the distal end of the socket, the EVLS acts as a locking mechanism, a sealing plate, and also a connecting plate to ensure that the distal end of the socket is sealed. The elevated vacuum locking system allows for vacuum pressures of up to 27 inches of mercury and allows for the fabrication of a single wall thermoplastic socket as well as a traditional laminated socket with PETG inner. Which brings us to our main point of this video, and that's the fabrication process. Other than the initial eval and casting process, the fabrication of the EVLS socket is one of the most important aspects of this system. Some key points for success for a properly fabricated socket are: number one, you want a total surface weight bearing socket. Two, you want a properly formed distal end so that the lock seats properly into it. Three, you want the socket to be properly tooled with the correct size drill holes so that they do not interfere with any of the sealing points of the lock. And also, you want a properly tested socket so that you ensure that there are no vacuum leaks when you fit it. Close attention to these key fabrication points will help ensure that your EVLS fitting is a successful one. The first step in the CAD/CAM process is obtaining an accurate image of the amputee's residual limb. Now, whether you're using a digitizer, scanner, or other means of obtaining the digital image, the most important part is that you obtain a model with three key landmarks, and that being the mid-patella tendon, the distal tibia, and the fibula head. And remember, if you're using traditional methods of fabrication, all the processes that we do here can be transferred over using hand tools and plaster. Once the digital model is obtained and the landmarks are properly placed, the modification process for the EVLS socket is fairly straightforward and does not stray very far away from what you've already learned about elevated vacuum socket systems. And that is simply a 4% global circumferential reduction. With the CAD/CAM process, it's easily accomplished by going in and simply scaling down the model by a certain percentage. And in our case, since we want a 4% reduction, we're going to scale it down 96% of its original shape. Once that scaling down of circumferences is accomplished, then there's only two more steps to the fabrication process, both of which are specific to the EVLS. The first process is adding a shelf, and we choose a medium W back shelf, and the height of the shelf will be 1/4 inch. The shelf is added simply to allow more relief for the hamstrings in the posterior region of the socket. The second process which we use for modification is adding a cylindrical adapter, which will be used to mount our tooling, which creates the distal void in the socket in which our EVLS lock will be mounted. Once these two processes are complete, the application of the trim line and preparation of the model for carving is all that's left to do before the model is sent to the carver. Once the foam model is done carving, we are ready to start processing the model and getting it ready for thermoforming. This process requires the use of PDI's foam extraction tooling, or FET kit. If you're using plaster, you'll be using the CFP 65-25, which is just a fabrication plate which will create the distal void for your EVLS lock. It's also worth mentioning at this point that all tooling is the same as you would use for any of our standard shuttle locks as well. The first process in which we will use is we will use a drill guide in order to mount our FET tooling. The drill guide goes onto the end of the model and center hole is drilled. Once the center hole is drilled, the push plate is mounted down inside the model and separating plate placed on top. At this point, you should have total contact between the foam model and the separating plate. Once this is accomplished, we will next use the center hole drill guide, which threads down into the center of the tooling and allows us to drill a hole directly through the center of the model, which is used for vacuum and also for later processing purposes. Once these processes are completed, the model is now ready for thermoforming inside the socket manufacturing unit. Once the foam model is processed and the tooling is properly mounted, it is ready to go inside the automated thermoformer or socket manufacturing unit. If you do not have a thermoformer at your disposal, you could also do a more traditional blister forming of the plastic at this point. Once the thermoplastic has been pulled over the foam model and the plastic has cooled, we will use PDI's Suction Socket Fabrication Tooling, or SSFT kit, to perform a few drilling operations to prepare the socket for extraction from the foam model. The first operation that we will perform is drilling up through the center of the model and into the push plate, which will help us find the center of the model. Remember earlier we threaded the 1/4 inch drill guide down into the top of the separating plate and drilled down through the center of the model. This is just a reverse operation to help us find the center of the tooling. Once the center hole is drilled, we will move over to the prosthetic vise and do some other drilling operations in order to extract the socket from the foam model.